This video is on finding multiples and the least common multiple of numbers. So begin with, what are multiples? Well, multiples are bigger versions of your number. Think of taking your number, in this case 8, and multiplying it times other numbers. So think of 8 times 1, 8 times 2, 8 times 3. So we would get 8, 16, 24. If we kept going, we get 32, 40, 48, 56, 64, and keep going. Basically, we're counting by eights, or think of it as skip counting. We're counting by eights. Here, we want to find the least common multiple of 8 and 10. We want to find the smallest multiple that both numbers have in common. So, I do the same thing with 10. Basically, I count by 10, starting with 10 times 1 is 10, then 10 times 2 is 20, 10 times 3 is 30, but I just keep counting by tens. I like to put a good 6 or 7 out there, sometimes a few more. And then go back and compare the two lists. What numbers did I have in common? And more importantly, what was the first number I had in common? Well, in this case, the first number that works for both 8 and 10 is 40. So if I was trying to build a number with an 8 and I was trying to build the same number with a 10, the first number, the smallest number that I could create using both of those is 40. It's the smallest multiple that's common to both 8 and 10. So I'm going to make a little bit of room here. Now I want to do the same thing for my second problem. I want to do 5 and 9. Again, the best way to find your least common multiple is list out the multiples of each number, compare the two lists together. So here I'm going to count by 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. And then I'm going to do the same with my 9s. 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 99. And then again, my goal is I want to know what's the smallest number that works for both of them. What's the smallest multiple that I can create from a 5, and I can also create from a 9. In this case, the first multiple that they both have in common is 45. So that's my least common multiple. So our last little bit is some of our word problems. Here, you have to be careful and read the problem carefully. It may be asking you to find the greatest common factor, the biggest factor or piece that I can make into either one of my numbers, or it might be looking at taking 2 or 3 numbers and looking at where are they all going to meet up somewhere in the future, what multiple works for all of them. So let's take a look at each one. First one says Faith spent the same amount of money on CDs as she did on DVDs. So there's our key. They have to have an equal amount. It said CDs cost $12 and DVDs cost $16. What's the least amount of money she could have spent on each type of disc? So here, I can't buy part of a disc, so my price is not going to get smaller, meaning I don't want to find factors of my number. That means instead I want to find multiples. So think of it as maybe I buy 4 CDs and 3 DVDs, something where the numbers are going to match up for me. So because I'm looking for bigger versions of my number, that means I'm looking for multiples. So I want to find out what multiple of 12, so what could I turn 12 into, meaning how many CDs could I buy at $12 each, that would match up with the dollar amount for DVDs. How many something at $16 a piece could I buy? So I start writing out my multiples for each one. So I'm going to count by 12s. And then I'm going to count by 16s. Remember, always start with the number itself as your first multiple. And then compare our two lists. We'll notice that in both cases, 48 was the first multiple for both numbers. Meaning if I wanted to spend the exact same amount of money on CDs as I did on DVDs, I would have to spend $48 on each. It's the first number that 12 goes into and 16 goes into. So in this case, I would buy 4 CDs and 3 DVDs, each totaling up to $48. So this one used my least common multiple. I needed to find a bigger version of my number. Now let's take a look at our next one. It said Rebecca had 20 table tennis balls and 16 table tennis paddles. She wanted to sell packages of balls and paddles bundled together. What is the greatest number of packages she can sell with no leftover balls or packages? So here we have two large amounts of something. We want to separate them out, divide them up, but we want to divide them up into equal groupings. We want to find a way of how do I divide up 20 of something and 16 of something into an amount that divides both of them up just as equally. We don't want anything left over. We want something that works for both of them. In this case, since we're breaking up the numbers, that tells me that I want to find the factors of the number. So I'm going to look for the biggest factor they have in common. What's the most I could put, the greatest number that could go in each one of those packages that divides 20 up and 16 up both nicely. So I'm going to make my factor tree. So I ask, what could I multiply together to get 20? Well, I could do 2 times 10. 2 is a prime number, so that one stops. But 10, I can keep going. 10 is really 2 times 5. Again, 2 is a prime number, so I can't go any farther. 5 is also a prime number, so I end up with 2 times 2 times 5. Now do the same thing with 16. 16 is really 4 times 4. 4 can be divided farther. That's really 2 times 2 for each of them. As we've had come up in several problems, 2 is a prime number, so I can't go any farther with those. So I end up with 2 times 2 times 2 times 2. Now, to find my greatest common factor, to find which factor is the largest but still works for both 20 and 16, I compare my lists. They each have a 2. They each have another 2. So there are 2 2's in common. So I take those pieces that they have in common, multiply them together, and I end up with an answer of 4. So Rebecca could put 4 table tennis balls and 4 table tennis packages, or she could make 4 sets of table tennis balls and table tennis paddles. 4 is a number that goes into both those in equal amounts. It's the biggest number that can divide them both up equally.